It's a long 12-hour day, flying out of Chile to one of the farthest points Operation IceBridge can reach in the Antarctic, the Getz Ice Shelf. We know from satellite measurements that this 300-mile-long floating ice shelf is losing mass, but with IceBridge data, we hope to find out something about why and how fast this ice is disappearing. After crossing the windy Drake Passage at high altitude, we descend and are treated to a tour of Antarctic ice in almost all its forms. We see different kinds of sea ice, from thin gray sheets to solid fields covered in snow and littered with icebergs. We see gigantic tabular icebergs, taller than a house and longer than a runway, that were once part of the largest piece of ice on Earth. And we see the ice sheets themselves, smooth in some areas, heavily crevassed in others. As we arrive at the survey area, we come across the calving front of the Getz Ice Shelf. This 10-story tall face is currently where mighty icebergs break off into the ocean. But it may not be the front of the ice shelf for long. Upstream, a crack is forming, threatening to calve off a new tabular iceberg and move the calving front inland. Even from just a few thousand feet above, the scale is deceiving. The crack looks like something you could jump across, but our laser data tells us it's 45 meters deep. And with our digital photography, we can estimate the width at more than 13 meters. But back to why we're here. We need to get a better handle on the bathymetry below the ice shelf. Basically, the shape of the ocean floor below this floating ice tongue. The shape will help us calculate the circulation of the warm water, well, comparatively warm water, that's eating away at the ice shelf from below. Our gravity meter, or gravimeter, actually senses the mass of rock below the ocean, giving us a picture of the grounding line, where the ice sheet leaves the support of land and begins to float on water. But that's all on the marine side. We also need to understand what's happening inland. Our laser data tells us how much the surface of the ice shelf is lowering, and our ice-penetrating radar tells us the shape and elevation of the bedrock below the ice, which helps us estimate how much ice will flow into the water and how fast. On the inland side, we pass by a ridge in Marie Birdland. Most of the distinctive mountains peeking through the thick ice here are extinct volcanoes from the Cenozoic era. They're a welcome scenic change from the wide, flat landscape that covers so much of polar regions. After collecting nearly 5 hours of data, we head for home and get a rare, clear view of the Antarctic Peninsula with its stunning mountain chain and almost alpine glaciers. Out the port side of our DC-8, we watch the sun set at its incredibly slow polar pace, cross the Strait of Magellan, and prepare to land back in Chile well after dark.